Module 1, Section 5, Objective 5. And it says, identify and apply the commutative property of multiplication. Okay, we've talked about this a little bit already, but I never just used the name. Okay, so if you look here, we have 5 on the top row, 5 on the second row. This is looking at the circles themselves. 5 on the top row, 5 on the second row. And they're grouping them to help count them better. Okay, so probably would write this one as 2 rows of 5 or 2 groups of 5, and this one is 5 groups of 2. Either way, those are going to be the same thing, aren't they? They're both equal to the 10 that we started with. They just grouped them differently. So the next section says, think of a situation that could represent each grouping. How are they the same? How are they different? Let's not worry about that too much. The idea is just grouping them together differently doesn't change how many there are, does it? Okay, so the first group is 2.5, or 2.5, 2 dot, or times 5 is 10. You never say multiply as dot, by the way. You always say times or multiply. And then the other one, the blue one, is 5 times 2 equals 10. And I've already explained how they fit the models. Okay, so write 2 multiply equations that represent this model. So if we have 4 this way and 3 this way. Okay, so we could have 4 rows of 3 would give me 12, or we could have 3 rows of 4, which would also give me 12. And it depends on what you mean by rows, right? So if I have 4 rows of 3, I would be looking this way. So there's 3 each way. If I had 3 rows of 4, I would be looking this way. At least that's my definition in my head. I didn't change the number of sections that there were. I just counted them in groups differently. Okay, and this is called the commutative property. Maybe you come up with that already in your head. Okay, the commutative property means that you can multiply in both directions and it's the same thing. So for example, 5 times 2 is the same thing as 2 times 5. You can multiply in either direction and it doesn't change the answer. Okay, so 4 times 3 is 12 and 3 times 4 is 12. Doesn't matter which order, it's still going to be the same number. So, using the commutative property, rewrite the statement if possible. Okay, so this one, 43 times 92, they changed it to 92 times 43. Just rewrote it. Okay, notice they used the same dot that you started with. Here it's 29 times 81, so they changed it to 81 times 29. They left the parentheses around the second number, but you technically could have rewritten it as moving the 81 with the parentheses to the front, and it would be exactly the same thing. It still means multiply. Okay, now on this next one, they didn't explain much about it, but division is not commutative. So for example, if I had 10 divided by 2, is that the same thing as 2 divided by 10? And it is not. Okay, so this first one means you had 10 whatevers and you wanted to divide them into 2 groups. Okay, this is easy, right? So each group has 5. But now the second one, you have 2 and you want to divide it into 10 groups. So each group would have a fraction, right? And a fraction technically is 1/5. These two are not the same thing. So division is not commutative. So you just put NA on those. Okay, so looking at the ones we have over here, first one, 24 times 56, we are going to rewrite it as 56 times 24. And that's it. Do you have to use the symbol that they started with? No. It's logical. You know what I mean? So on E, if they use parentheses, it's logical to use parentheses. But if I just rewrote it using a dot, it means exactly the same thing. It means we've changed the order, and that's what the commutative property is. Okay, so just make certain that you change the order, and then you can use whichever symbol you want. Okay, now F, can we change the order and have it mean exactly what we started with? And no, you cannot, because division is not commutative. So this one is not applicable.